Okay, so in today's lesson, we are going to learn what are elements, mixtures, and compounds. You have already covered this in lower sec science, so for this segment, we are just going to do a recap. So elements, again, are pure substance that cannot be broken down into two or more simpler substance by chemical methods. Right? Every element can also be found in the periodic table. Examples of elements are, for example, metals, which are found in group 1, 2, and 13. And one specific example of this would be sodium, which in the periodic table has the symbol of Na. Secondly, monoatomic noble gases, which are also found in group 18, right, are also examples of elements. More specific example of group 18 monoatomic noble gas elements are helium, argon, and neon, which have these symbols respectively. Last but not least, in group 17, we also have the diatomic molecules, and specific examples are fluorine, chlorine, bromine, iodine, and astatine. On top of the group 17 diatomic molecules, they are also seen in hydrogen, nitrogen, and oxygen. In terms of the particle diagram, the monoatomic noble gases, which are found in group 18, can be represented in these blue circles, whereby atoms exist individually. On the other hand, diatomic molecules can be found on this red particle diagram, whereby the atoms exist in pairs. So again, atoms, recap, are the smallest particles of an element. Molecules, on the other hand, refers to small group of atoms, usually two or more, which are chemically combined. Okay, with that, please fill up page 2 of your notes with the red words. You may pause the video to do so. Compounds are pure substances that contain two or more elements chemically combined. The particle diagram of compounds look like this here. For the particle diagram on the left, whereby you have one red circle and two white circles, right? This is an example of, let's say, water molecule. Water has the chemical formula of H2O, so we can see that the two hydrogen atoms in water are represented by the white circles, whereas the one oxygen atom in water can be represented by this red circle. On the other hand, on the right, we have one blue circle with three white circles. This could be an example of, let's say, ammonia, whereby there is only one nitrogen atom and three hydrogen atoms. Therefore, this blue circle could have represented the single nitrogen atom, and these three white circles could have represented the three hydrogen atoms. So, compound has a chemical name, and in this case, the chemical names are water and ammonia respectively. And the chemical formula they have are H2O and NH3 respectively. The ratio of the number of different atoms in a compound is fixed, and this is what we mean by fixed composition. So for example, water will always be H2O, whereby there are two H atoms and one O atom. We cannot say that water is H3O or H4O. It will always be H2O in fixed compositions. The composition of the compound is separated by chemical methods, such as thermal decomposition or electrolysis. So for example, if I want to separate out water into hydrogen and oxygen atoms respectively, I will have to do chemical methods to break them down. The same applies for ammonia, since ammonia is also a compound. To copy this into page 2 of your notes, you may pause the video to do so. Lastly, let's talk about mixtures. Mixtures are made up of two or more substances that are not chemically combined. They can be separated by physical methods. and they are not present in fixed compositions. They also do not have any chemical symbols or chemical formula. The particle diagrams can be seen here. So for example, in the first diagram, we are talking about mixture of atoms. As you can see, the blue and red circles are presented individually. In the second diagram, right, it shows a mixture of element and compound. So element in this case are, let's say, the blue circles that are existing in pairs. Whereas compound, on the other hand, shows us that the red and the blue circle are chemically combined. And with that, this whole diagram is a mixture because the blue circles and the red and blue compounds, they are not chemically combined, and hence it is a mixture. Last but not least, right, we also have a mixture of atom, element, and compound. The atom in this case refers to the red circles, whereby they are existing individually. The element in this case are the diatomic molecules, whereby there are two blue atoms existing in pairs. And last but not least, the compound refers to the red and blue circle, which are chemically combined. You may copy this into page 3 of your notes. Okay, finally, let's do a summary in page 4 of your notes. Element are pure substances. Compound are also pure substances, whereas a mixture is not a pure substance. Okay, elements are found naturally, and they can be found directly from your periodic table on its own. Compound, on the other hand, are formed by chemical changes, while mixture are not formed by chemical changes. Composition-wise, elements exist in fixed compositions, so are compounds. Mixtures, on the other hand, exist in varying compositions. Elements cannot be broken down into simpler substances. Compound, on the other hand, we can separate them into constituent elements by chemical means. Mixtures can be separated into the component substances by physical means. For melting and boiling points, elements have fixed melting and boiling points, so do compounds. Mixtures, on the other hand, do not have fixed melting and boiling point, and instead they melt and boil over a range of temperatures, and this has already been taught in chapter 1.